Yes, Mr.
Hello class.
Hello.
Good morning.
Good morning, sir.
How are you?
I'm alright, thank you, sir.
How has been your weekend?
Kawa, money, boy, and others.
How was your weekend? Sema.
Yes, but I tried to maybe she was most of the discussion.
Are you sure?
She was
You tried to discuss with first?
Yes, I tried to discuss with them, but it was almost the same case. But I was raised
Then let's discuss. So far, I want to take a roll call of your names and see how this happens today. Today is 18th March 2025. So, Disha Goodman, Sabano Tabitha, Rama Esmas, Mr. Alex. Alex is something like it.
Yes. Alex was
I think he has touched. Okay. Same up as well.
now.
Okay. You have come.
When
Having became late. Someone said that is now budget. You sure?
no sir. Decline.
Check your William.
six.
So according to the average attendance, shows that most of the members are present. So I can now begin my lesson. And the class today, we are going to look at something very interesting, and that is work, energy, and power. So we have always done work in a very team, in different ways. So I don't know, guys, how can you measure the amount of work that you do every day? Have you ever tried to measure the work that you do? Maybe lifting things, jerry cans, walking, running. Have you ever tried to notice the input, the work that you do? Have you ever tried to measure that work? Yes.
Me personally, I've never tried, but in my mind, I know I do work, but I've never tried to measure the amount of work.
Is it measurable anymore? Anyone who thinks that it is measurable?
Yes.
You have an idea?
There are things that you can measure. That's why we are here today.
Okay, so our friend Tabisa said that work can be measured, and today I want us to look at this work. And the first question posed to you, I want to know, what do you know about work, energy, and power? What is the difference between those terms, and what do you know about them? Yes.
And let's try.
Okay.
I can say work is energy. Then power is energy. And
Work is energy, then power is energy and time.
So, calm down. So, power and work, they really relate to energy. They are kind of related. Those three topics are really related.
Thank you so much, Sabano. So she has tried to relate work, energy, and power, and she has given us her view. Any other person with another answer about the definitions of work, energy, and power, and their relationship? Yes. Semakura, you can tell us.
Work, energy, and power. I think work is the ability to do something. Energy is the composition of what really you have that can help you to do something. And power is the ability to use the energy to work.
Good try. Can you clap? Yes. Yes.
I want to argue with Semakura.
Yes.
Semakura, you said work with the ability to do something. Are you not defining the energy?
I don't know, but it was just giving a try. But I think it is that thing, according to me.
Okay, what do you know about work, Mr. Onesimus?
Work is the energy. Work is energy.
And what is energy?
Energy is the rate of doing work.
No,
Okay, what are you saying, Goodman?
energy. It is power that energy is the ability to do work. When power is the rate of doing work. Yes.
Good, and that is so.
I support you.
Onesimus, you can read for us what is on the board.
Energy is the ability to do work.
Energy is the ability
To do work.
So class, energy is the ability to do.
Work.
Repeat after me. Energy is the ability to do.
Work.
Then, Mr. Goodman, you are going to read for me the definition of work.
Work is the product of force and the perpendicular distance moved in the direction of force.
Class, repeat.
Work is the product of force and perpendicular distance
Moved in the
in the
direction
direction
of
of
force.
force.
Sabano, tell us, what is the SI unit of work?
Since, according to my research, since work is related to energy, I suppose that they have the same SI unit, whereby if energy, the SI unit of energy is joules, then work is also joules. It's measured in joules.
Okay, so good try. Thank you. Now, in the physics, work has yes.
I'm used to that. That's why I joined it.
Yes.
But
I talked to the head teacher about your issue, and we are trying to sort it.
yes, teacher, my teacher of physics at Mbona SS did not tell me the meaning of SI. What do you mean by SI units?
Okay. My friend Semakura has posed a question, and this question is to you guys whom I taught from senior 1 up to now. And he's asking the meaning of SI unit. Yes.
SI stands for Standard International Unit. International, yeah, the international norm. So if they say SI unit for mass, kilogram, maybe Uganda is a kilogram, Kenya is a kilogram, even Europe is a kilogram.
Yes.
I'm still not getting.
Well, I told you this work is in your home. And yes, let's look at the smallest measurable what?
But why did you ask that question?
But the question is community.
But why did you ask
I'm not the one.
I'm imagining when the teachers are really searching.
I wanted to push it to
When
you.
You would have said that is your homework. Then you continue.
Okay, let us
First you decide what to decide.
Aya, cameraman.
just continue.
Let's get me now with
So, my friend has asked about SI unit, and I told this in senior one, so I'm not going to repeat this. Instead, I'm going to leave it as that, as a homework. So, what you are going to do for me, everyone will make a write-up about the SI unit, and you give me some physical quantities and their SI units. You want at least to give 5 physical quantities and their SI units. Yes, that is homework. You try it, you bring it for marking, then we shall see, depending on what you have tried. Okay, let's go ahead and look at the mathematical computation of work. So my friend Abano said that work is closer to an object because of displacement. So what is the formula for calculating this work? Because we say you guys are doing physics. In physics, everything we shall be calculating. So once you're doing physics, you expect some mathematics, and therefore we are going to be doing some calculations on every concept. So on work, we're going to look at some computation. How can we measure this work? How can we measure what? This work. And the way of measuring this work, I want Sabano to tell us, how can we measure this work?
and let's try.
Yes.
Okay, I just want you to say how can we measure. Do you want this one?
I want a formula for
Formula, yeah, okay.
calculating.
Yeah, according to the definition, work is force, product is force, and product means what? Multiplication. So I can say work is force times distance.
Work.
It's force times distance.
Good. So that is according to her, and she has said work is the force times distance. According to the definition of work, that is the formula we shall be using. You can read for us the formula presented by W.
It shows that work is equal to force times distance cos theta, where theta is the angle of elevation. It depends. If it is linear, on the horizontal line, it is force times the distance. If it is at a given angle, maybe someone is moving at a given angle of elevation, then you use that angle, cos theta.
Okay. So they are saying that work is given as force times distance, cos theta times d cos theta. This d is representing displacement, and therefore this cos theta is trying to bring for us the expression for distance. So d cos theta is distance. Cos distance is the length between two positions. Yes, so it is trying to make it directional. Yes, so I'm going to give some scenario questions about that, and you will try them in your books. And so I have one question here, and you're going to try it. So it is saying, let us have somewhere right, and note this question. It's going to be, you'll submit it in the next lesson, and it's about how to complete work. So the question is saying, Fiona's mother went to market to buy different items for use. Assuming that you were tasked by of 32 kilometers, meaning that the distance from back to home is 32 kilometers. And the items weigh 20 kilograms. The items weigh 20 kilograms. I'm saying, yes, assuming that you have to carry these items back home, and this is 50 kilometers.
Spelling in kilometers.
It is here, short term, and maybe, yes. So it is 50 kilometers back home, meaning that the distance from home to market is 50 kilometers, and the mass or the weight of these items is 20 kilograms. I want you, as a learner of physics who has studied work, I want you to compute the work done by this, by the work done by this scope. Yes, I want to give you that you have relevant. So we're going to do this. I want you to discuss it, and you see how you can come up with this. So you can discuss this.
I was. What is the time? 17.
Okay, I'm marking. One, two, have you discussed? Yes, I can see this girl is not. Okay. Yes. For the try. Wow, this group is very good. It has already got the answer within a minute. That's good. Have you guys calculated?
I'm not waiting anymore.
So, what have you eaten? This, no correction. I want you to use the formula for work and calculate. This angle is not given here, so we are not using the angle. Okay, so you try that.
Yes, I'm gonna.
Okay, so then almost coming to the climax of what I've prepared for today. Though we shall continue with this topic because we still have a lot to cover and understand about work. We are going to look at power in the next lesson, and we will also look at work and the relationship. Okay, guys, I want to ask simple questions. But before I ask, I want you to ask me. You can tell me, what are you going to do today, what I get to do, and we see how we can conclude this lesson.
Yes. According to the lesson that we have attended today, I have learned that whenever you apply some force and you move a given distance, a certain distance, then you have done some work. And if you don't move any distance, though you are applying some force, the work done is zero. That's what I have picked in today's lesson.
Wonderful. Wonderful, wonderful, wonderful. Yes, you are just busy there. Okay. Tell us, what have you learned?
I've learned that I'm now going to use the formula finding power and work. Yes. The SI unit that you join about it, as you said. I'm going to also update the notes. I realized the notes I have from the other school, not really good notes from Ghana SS.
But I said
Yes.
use a long point book,
The long one book.
runner's book, senior 2. That is the one we are using. And I don't want you to use the teacher's guide, please. Don't use that, use the runner's book. Yes, good man.
Yes.
You have been in class, but I haven't had anything like contribution. What have you learned today?
Today I've learned that power is the rate of doing work. The last we need energy to do work. So energy is doing work. So we need energy to do work. Whereas power, power is that type when you're like for power, we say that it's the rate of doing work. That means you have to involve in the element of time.
Okay, so this man is even ahead. He has already read something about power. I want you to tell us about work. What have you learned about work?
Work, I've learned that for you to do work, there must be some force, there must be a distance moved by a certain force. And when no distance is moved, that means work is not done. So that means it's moved. Thank you, sir.
Okay, that's good. I hope you listen and try to understand this, and we shall add on next session. And I think we can at the end of the chapter. We should combine on and then you have to make a project. Then I will see and see the application. Of course, this has been a good class. Thank you so much. Let's meet Wednesday. Actually, exactly 7. I will be in class.